Hello, myself Dr. B.J.D. Kalyani, working as Associate Professor in the Department of Computer Science and Engineering of Institute of Aeronautical Engineering. In this video, I will discuss about the Module 1 Question Bank questions. The first question is, demonstrate the basic instruction types in assembly language programming. What is computer language? A computer language is mode of communication by the user with the computer. There are three levels of programming languages: low-level programming language, middle-level programming language, and high-level programming language. The low-level programming language is very close to the computer and can be easily understood by the computer. It is framed with the binary information, zeros and ones. The instructions can be given directly with the binary format so that the machine can understand easily and execute the programs quickly. But from the user perspective, the machine language is very difficult to understand and very difficult to code, debug. To facilitate readability, some code words can be introduced in the machine language, the low-level language. That codes are generally referred as mnemonics. The language that is framed with these mnemonics and operand data is generally referred as the assembly language. But computer can understand only the binary information. So these mnemonics need to be converted into binary form. So the assembler is the software which converts the assembly language program into machine language so that the computer can easily understand the program. Both the machine language and assembly language are considered to be the low-level languages. So, assembly language comes under the category of low-level programming language and can consist of some mnemonics. And it is very close to the hardware of the computer. So, what is assembly language? Is a type of programming language that communicate with the hardware of the computer. So, the three levels of languages are low-level language. Under these, the category are machine language and assembly language. The next category is middle level language. It's a combination of low level language and high level language. High level language is human understandable languages, generally referred as high level language. In this, the programs can be framed with the natural language English. So, an assembly language is a low-level programming language designed for a specific type of processor. So, the language is processor dependent. The mnemonics can vary from processor to processor. So, it's a lack of portability. Assembly language programming consists of mnemonics that is translated into the machine codes. If you are observed here, the machine code can be generally framed with the binary information in the form of zeros and ones. But to understand the readability can be very low in case of the machine language. To facilitate readability, the mnemonics can be introduced in the assembly language. So here MOV is the mnemonic which can instruct the system what operation to be performed, and the next the operand on which data this operation can be performed can be specified in the assembly language. So assembly language consisting of mnemonics that is translated into machine code. Assembly code can be converted to machine code using the assembler. The translator used for the conversion of assembly language program to the machine code is the assembler. Example, how the instruction in the assembly language program can be MOV BX, B. Here this is the mnemonic and these are the operands. What are the advantages and disadvantages of assembly language? The assembly language can be easy to understand and use. So mnemonics are there, so modification and updation can be done so that the debugging process can be easily performed, high efficiency, more control on the hardware. What are the disadvantages of assembly language program? It is machine dependent. The mnemonics can vary processor to processor, but it requires translator. Assembler is the translator, but it is difficult to learn and write programs. The mnemonics has to be remembered by the user. Slow development time and it is less efficient. So here the machine code can be given directly in the binary form. So it can be directly understood by the computer. But in case of assembly language, some mnemonic can be used. So this mnemonic need to convert into this binary form by using the assembler. So assembler is a software which converts the assembly language program to the machine code. In case of high level language, it is generally written in natural language that is understood by the user using the English like, so that a translator is required for the high level language code also. So the compiler and interpreter can be used to convert the high level language code into the machine code. So an assembler is a computer program that converts assembly language program into the machine language instruction. So this is the assembler or the translator which receives assembly language code and convert into the machine level language code. The example of assembler is 6502 assembler, ARM assembler are the examples of the assemblers. So how the assembly language program can be processed? So a operating system is required for controlling of the computer, and a text editor can be required, or a word processor software can be required to type and edit the program, and an assembler program, a test program can be required for the assembly language program process. How the instruction format in the assembly language? So generally the instruction can be specified with a label, next instruction, comment. So there are three parts in the assembly language instruction: a label, instruction and a comment. A label and comment are the optional part. The instruction is the compulsory part. In case of any branch and jump instructions are used in the assembly language program, then the label can be used. Otherwise, it's an optional part. Comment can be for the user reference. So, if for any instruction user-defined comment can be written, this section can be used. Otherwise, it is an optional part. The compulsory mandatory part is the instruction. So here the mnemonic, the opcode can be given, and the operands on which data this operation can be performed can be specified of the mnemonic. So that is the format of the instruction. So here is the example. Again is a label. Label can be defined and can be terminated with a colon. And here add is the mnemonic, and here two arguments can be specified. First one is the destination operand, second one is the source operand. Next, here this is the comment. So in this way, the instruction can be specified in the assembly language program. Now we will discuss about what are the types of instructions that are available in the assembly language program. So there are three types of instructions. One is data transfer instruction, Second one, data manipulation instruction. Third one, program control instruction. Generally, the data transfer instructions can be used to transfer data between the resistors, memory, or with the input-output devices. Without changing the content, the data can be transferred. And data manipulation instructions can facilitate the processing capability to the computer. Program control instruction generally used to alter the execution sequence of the program. Now we'll discuss what are various instructions that are available under each category. The first type of instructions are the data transfer instruction. The data transfer instructions move data from one place in the computer to the another without changing the data content. So generally the transfer can be take place between memory and processor registers, or between processor register and input output devices, or in between the processor registers itself. And a list of data transfer instructions are load. The mnemonic used for the load is LD. Next, store. Mnemonic is ST. Move. Mnemonic is MOV. Exchange XCH. Push PUSH. Pop POP. Input IN. Output OUT. So these are the list of instructions come under the category of data transfer instructions. What is load instruction? Load is used to designate the transfer to a processor register. Generally, the accumulator register can be loaded with the content. Next one, store. Used to designate transfer a register to the memory. So here, if it all the data transfer exists between processor register to the memory, accumulator to the memory, then the store instruction can be used. Move is used to designate transfer between the processor registers. Exchange is used to swap the values between the content of the two registers. Input and output state mnemonics can be used to activate input and output peripheral devices. Push and pop are concerned with the stack operation. So when data is to be inserted in the stack, push mnemonic can be used. If at all the data can be retrieved from the stack, pop mnemonic can be used. How these can be applied? So move R2, R1. So the content of the register R1 is moved to the register R2. Push R1. The content of register R1 can be moved to the stack. Pop. What is the content that is pointed by the stack pointer SP? That content can be retrieved. Exchange. The swapping of values between the content of two registers R1 and R2 can be take place. R2 value can be transferred to R1, R1 value can be transferred to R2. In this way, the data transfer instructions can be used in the assembly language program. The next category of instructions in the assembly language is data manipulation instructions. Data manipulation instructions can provide processing capability and computational capability for the computer. Here there are three varieties of data manipulation instructions: arithmetic instructions, logical or bit manipulation instructions, shift instructions. What are arithmetic instructions? Arithmetic instructions generally used for computational purpose. They are used to perform the arithmetic operations. The list of arithmetic instructions are increment, the mnemonic used is INC, decrement, mnemonic used is DEC, add, ADD, subtract SUB, multiply MUL, divide DIV, add with carry ADDC, subtract with borrow SUBB, subtract reverse SUBR, negate NEC. So these are the list of arithmetic instructions. So increment is used to add a value 1 to the content of the resistor. Decrement is used to subtract a value 1 from the resistor. Add, subtract, multiply and divide can be used to perform the basic arithmetic operations on the specified resistor content. The addition can be done with a carry bit with the help of ADC mnemonic. Subtraction with a borrow can be performed with the sub-B instruction. Negate mnemonic can be used to produce the 2's complement of the resistor content. How these arithmetic instructions can be used? INC R1. The content of resistor R1 can be incremented by 1. That is, which is exactly equivalent to R1 is equal to R1 plus 1. Decrement R2 means the value of the resistor R2 can be decremented by 1. Add means the value of R2 and R1 can be added and the result is stored in the R1. R1 is equal to R1 plus R2. Sub R1 minus R1 comma R2 means R1 is equal to R1 minus R2. So in this way the arithmetic instructions can be specified in the assembly language. The next variety of instructions are logical or bit manipulation instructions. Logical instructions perform binary operations on strings or bits stored in the registers. So, a single bit can be used in case of logical or bit manipulation instructions. So, they are considered each bit of the operand separately and treat it as the Boolean variable. So, by proper application of the logical instructions, it is possible to change the bit values to clear a group of bits or to insert new bit values to the operands stored in the registers or the memory words. The list of logical instructions are clear with a mnemonic CLR, complement with a mnemonic COM, and or exclusive or XOR, clear carry CLRC, set carry SETC, complement carry COMC, enable interrupt EI, disable interrupt DI. So clear can be used to transfer zeros to the specific register. Complement is used to produce one's complement of the operand specified. And or exclusive or are used to perform the logical operation of or and exclusive or. Clear carry is used to store zero value to the carry bit. Set carry is used to store one bit for the carry bit. Complement carry can be used to produce one's complement of carry bit. Interrupt can be enabled with EI and can be disabled with the DI. Interrupt are the signals that are generated. When an interrupt is raised, the CPU can stop the current program execution and can return to the interrupt service routine. After completion of the service, it can resume the main program. So, to enable the interrupt, EI is used. To disable the interrupt, DI can be used. So, how these logical instructions can be applied? So, CLR R1, so clearing the register R1, so 0 values can be stored in the R1. COM R1 complement, one's complement of R1 can be produced. And logical operation can be applied between the registers R1 and R2. What are shift instructions? Shift instructions operations in which the bits of the word are moved either to the left or to the right. There are three types of shift operations are available. One is the logical shift, second one is arithmetic shift, third one is circular shift. So to support either in left direction and in the right direction for these three types of shifts, the 6 operations can be generally used. So logical shift right can be specified with a mnemonic SHR. Logical shift left can be specified with SHL. Arithmetic shift right SHRA. Arithmetic shift left can be specified SHLA. Rotate right, that is the circular shift ROR. Rotate left ROL. Along with carry bit, this rotate shift operation can be performed on the right side with RORC and on the left side with ROLC. How these shift instructions can be applied? So SHR R1, 1, the content of R1 can be shifted right side with a bit value, 1 bit value, and SHL R2, 2, the content of R2 can be left shifted with a 2 bit. Next, SHRA is used for arithmetic shift on the R1 with a value 1 bit, and SHLA R2, 1 shift left, arithmetic shift left of the content R2 by 1 bit. Rotate right R1 content, rotate left R2 content. Along with the carry, rotate right R1 content. ROLC R2 means rotate left along with the carry on the content of the resistor R2. So these are the variety of the data manipulation instructions. One more category is there, that is the program control instructions. The program control instructions can be generally used to alter the execution sequence of the program. So the flow of execution can be changed by using these types of instructions. This flow can be changed conditionally or unconditionally. Conditional branching means the condition can be checked. If it all satisfied, then only the execution sequence of the program can be altered. Unconditionally means without checking the condition, the sequence of the program execution can be altered. The list of instructions available under this category are branch, BR, jump, JMP, skip next instruction, SKP, call procedure, CALL, return from the procedure, RET, compare, CMP, test, TEST. So here branch can be used to move to the specific label so as to the execution sequence can be altered. Jump is also used for the similar purpose. They are the unconditional sequence, execution sequence, changing of the program execution sequence. Skip is skip to the next instruction. Call and return is used in case of procedure calls. Whenever a call statement encountered in the program, the assembler can shift to the procedure and executing the subroutine until the return statement. As soon as return statement is found, it can resume to the main program. Compare and test can be used to compare the value of the content of the resistor so that the bits can be changed accordingly. So how these shift operation program control instructions can be applied? Branch address 1, the specific address, the branch operation can be jump, JMP again is the label so that the program sequence can be altered to this label. Skip to the next instruction, call the function 1, return, compare R1 with a 0 value, test R1, R2. So these are the program control instructions. How this assembly language program can be written. So here first the data values has to be moved. So 7 value can be moved to the DX register and 9 value can be moved to the AX register. After that add operation can be performed. In this way the assembly language program can be written. So what are the types of instructions in the assembly language means? Majorly 3 types. So majorly they are of 3 types. Data transfer instructions, data manipulation instructions, and program control instructions. Under manipulation instructions, again 3 categories: arithmetic instruction, logical instructions, shift instructions. In the shift, again 3 categories: logical shift, arithmetic shift, and circular or rotation. So these are the variety of instructions in the assembly language. Next, move to the next question. List the various components of computer system and show with the diagram. So first we have to discuss about the definition of the computer. A computer is an electronic machine which receives data from the user, processes it and gives the output with a very high speed and with greater accuracy. So from the definition, majorly 3 operations can be done with the computer. One is the input, second one is the process, third one is the output. So to support these 3 operations, 3 functional units are constructed in the computer. So this is the input operation. Process operation can be accomplished with the storage operation and the output operation. To support these operations, the functional units employed in the computer are the input unit, central processing unit, output unit. The input unit takes the data from the user and supplies to the CPU in a computer readable form. So variety of input devices can be used in the market. We will discuss now the input devices. Next, central processing unit is used to perform the processing and computational capability to the computer. And here the CPU can have 3 sub-units. They are arithmetic and logical unit, control unit, memory unit. The next unit is the output unit, which is used to represent the computer generated information in a user understandable form. Variety of output devices can be used like monitor, printer, etc. First we will discuss about the input unit. Input unit is the majorly provide man to machine interaction. So it takes data from the user and convert into computer readable form and supplies to the CPU. So a computer can have more than one input devices. Depending upon the user requirement, these devices can be connected to the system. Keyboard and mouse are the majorly used input devices. So this is the layout of the keyboard. It is similar to the typewriter. QWERTY is the inventor of the typewriter. So this is called QWERTY layout, which can have the capacity of giving the alphabets. Numeric keypad is also there, and functional keypad can be located on the top of the keyboard. These functional keys function can vary from software. Next variety of input device is the mouse. Mouse is used for the graphical user interface. If a menu is displayed, from that one option can be selected, then the mouse can be used. So it is a pointing and clicking device. Variety of mouses are available. Next type of input device is magnetic ink character recognition (MICR), which is generally used in the bank. On a DD, the DD number can be quoted with a specialized magnetic ink. To capture this DD number directly, this MICR can be used in the banks. Next, light pen. So a pen is attached to the video visual display unit. So when the pen nib touches with the screen, that part can be magnetized. Generally, the pen can be used to give the pictorial input to the computer. Next is optical marks reader. Those can be used for the competitive exam paper evaluation. Scanner can be generally used to give document and photos as the input. Barcode reader can be employed in shopping malls and libraries to scan the barcodes. Magnetic card readers can be used in the shopping malls to scan the debit and credit cards. Joystick can be used in the gaming applications. Next functional unit of the computer is the central processing unit. The CPU can have three subunits: control unit, arithmetic logical unit, and the memory unit. The layout of the CPU is like this. What is control unit? The control unit controls and monitors the other functional units with the clock signals. The sequence counter in the control unit generates these clock signals. By using these clock signals, the operations of other functional units can be controlled and coordinated. So, control unit issues commands to transfer data from input unit to memory unit and arithmetic logical unit. So, here it can also control the signals to read and write the data from the memory. And it can also transfer ALU generated results to the output unit. Thereby, the control unit coordinates and monitors other functional units of the computer. This is the layout of the control unit. So, next subunit of the CPU is arithmetic and logical unit. In short, it is referred as ALU. ALU performs all arithmetic operations like addition, subtraction, multiplication, division. And the decision making capability can be incorporated with the logical operations like AND, OR, NOT. The layout of the ALU is like this. Next subunit of CPU is the memory unit. The memory unit generally used for the storage of user programs and data. Majorly it is of two types, primary memory and the secondary memory. The secondary memory can be generally referred as auxiliary memory. This is the layout of the memory unit. Next unit is the output unit. Output unit provides machine-to-man communication. Whatever information or the result that is generated with the computer can be represented in an user understandable form by using this output unit. A computer can have one or more output devices to be connected. Generally connected one is monitor or screen or video and the printer. So this is the visual display unit, the screen, which can be used to display the information on the monitor. So this information is generally the soft copy of the information. When the user required to take the hard copy of information, printers can be used. Variety of printers are available like inkjet printer, laser printer and dot matrix printer. When the user needs the voice output, then speakers can be employed. So these are the various categories of output devices. So these are various functional units. So majorly to support three processing operations like input, process and output. Input unit, central processing unit, output unit can be employed in the computer. Next question is, explain the functions of the processor registers and sketch the block diagram. What are processor registers? So processor registers are very fast, small storage available on the central processing unit or the processor itself. So registers are a type of computer memory used to quickly accept, store, transfer data and instructions that are being immediately used by the CPU. A processor register may hold an instruction or storage address or data. Computer need processor register for manipulating data and a register for handling the memory addresses. So registers are very fast computer memory that can be used to execute the program and operate efficiently. So the sole purpose of the registers are having fast retrieval of data for the processing of the CPU. So here some special purpose registers are employed. MAR is memory address register, PC is program counter, IR is instruction register, MDR is memory data register, R0 to Rn is the general purpose register. The number can be depending upon the processor. So these are the variety of CPU registers. And here is the memory configuration of the registers. So here this is DR is data register which is of 16 bits size, that is 0 to 15. It is generally used to carry the data that can be read or written in the location of the memory pointed by AR register. So AR register is the address register which is of 12 bit size which can use to carry the memory address. Next, AC is the accumulator register which is of 16 bits size and can be used for arithmetic operations and processing of the computer. Next is IR register, instruction register which can hold the address of the current instruction. Each is of 16 bits size. TR is the temporary register of 16 bits size. INPR outer are of 8 bits of each and can be used for input and output purpose. So these are the functionality of the registers. Data register hold the memory operand. Address register hold the address of the memory. Accumulator is the processor register. Instruction register hold the instruction code. Program counter holds the address of the instruction. Next, temporary register hold temporary data. Input register holds the input character. Output register carries the output character. So these are the functions of the registers and how these registers can be represented in the RTL. So the registers can be represented in the 4 basic ways. The first way is the register can be represented with a capital letter by referred with its name. So here R1 is the register name and can be represented. Next, second notation is used to represent the data that can be held in the register. Third representation is to represent the storage capacity of the register. So here PC is the register name and which can be hold 16 bits size. So it can be represented with 0 to 15. So here a computer word is combination of 2 bytes. So this 16-bit register can be represented with 2 byte notation. So here the PC can be represented with 0 to 7 bit. This is the lower byte of the register and 8 to 15 is the higher byte of the register. That's why PC within parenthesis L can be represented to denote 0 to 7, the lower byte of the PC register. And PC within parenthesis H can be represented to denote higher byte of the PC register, that is 8 to 15 bytes. In this way, the registers can be notated in the register transfer language. And in the RTL, the basic symbols that can be generally used is letters, which is used to denote a register, MAR, R2, like this. Parenthesis, to denote a part of a register, R2 0 to 7 bit, R2L, the lower byte of the register. Arrow is used to denote the data transfer of information. Comma is used to separate the two micro operations. How they can be used in the RTL? So simple transfer can involve, here the arrow can be notated here. So R1 content can be moved to the R2. Conditional transfer can also be take place. P is the Boolean or control function. If at all P holds the 1 value, then only R1 content can be transmitted to R2. Next, sequence of operations. So those sequence of operation can be separated with a comma. So transfer of R2 content to R1 is a 1 micro operation, and conditional transfer is another micro operation. These two micro operations can be separated with comma. In this way, the registers can be notated in the RTL. Next question, list various instruction format and illustrate with an example. So here, to perform any functionality, the user need to supply the program. A program is a set of instructions that specify the operations, operands and the sequence by the processing has to occur. This program and data can be stored in the memory. So, instruction code is a group of bits that instruct the computer to perform specific operation. So, for the execution of the program, the instruction cycle, execution cycle generally consists of 4 basic steps. The first step is fetching the instruction, second one decode the instruction, third one fetch the operand, fourth one execute the instruction. So, a program is collection of instruction. For each instruction, the computer can follow this instruction cycle. So, the first step of instruction cycle is fetching the instruction. So, from the memory, the instruction can be fetched and it can be stored in the register, IR register. So, this IR register can be used to specify the instruction code. So, in which format the instruction is represented in the IR register? IR register is of 0 to 15 bit size, that is of 16 bit size. So, in these 3 fields can be used to represent. One is the operand or the address. Second one is opcode, this is called the instruction code. Third one is the addressing mode. So, here the basic part of the instruction, that is 0 to 15 bits, has to be divided into 3 parts. 0 to 11 bits is used to represent the address or the operand. 12 to 14 is used to represent the opcode. This is the instruction code which can use it to specify what operation to be performed on this data. Next, 15th bit is used to represent the addressing mode, either direct or indirect. This direct and indirect addressing field is represented with I. If I value is 0, it is a direct addressing mode. If I value is equal to 1, then it is a indirect addressing mode. So, what is this direct and indirect addressing mode? Consider this example. So, here the instruction can be specified 0 add 457. So this is the operand part. This is the instruction code, add operation to be performed, and this is the addressing mode. The I value is 0 means it is a direct addressing mode. And here this is the address. So 457 address in the memory, the operand is available that can be used along with the accumulator content to perform the addition operation. This is the direct addressing mode. But in case of indirect addressing mode, I value can be the 1. So in this case, the address that is specified in the instruction can be used to specify the effective address. So that is one more memory location can be specified here. When the compiler travels to that location, there itself it can find the operand. So 2 cycles can be required to fetch the operand in case of indirect addressing mode. So this operand can be used along with the accumulator to perform the addition value. So that is the difference between direct and indirect addressing mode. Depending upon the instruction code, the basic type of instruction can be identified. So what are the instruction formats? 3 types of formats can be available. First one is memory referenced instructions. Second one, register reference instruction. Third one, input output instruction. Memory referenced instruction means this opcode value can be ranged from 000 to 110. In case of register reference instruction, the I value can be 0 and the opcode can be 111. Those instructions are the register reference instruction. The third category is input-output instruction. In this case, the I value can be 1 and the opcode can be 111. So these are the 3 types of instructions. Now we'll see what are memory referenced instruction. Memory can be referenced to fetch, to perform the intended function, either direct access or with the indirect access. And the list of memory referenced instructions are AND memory word to the accumulator, add memory word to the accumulator, LDA load memory word to the accumulator, STA store content of accumulator in the memory, BUN branch unconditionally without checking the condition, branch operation can be performed. BSA branch and save return address. ISZ increment and skip if 0. So these are variety of memory referenced instructions. How these instructions can be applied in the assembly language? The first one is AND. So whatever memory location that is pointed by AR, the content from the memory can be fetched and can be perform AND logical operation with the accumulator. In the RTL, this is the operation that is specified. Next is the AND. In case of this, the content of the memory has to be added with the accumulator. LDA. The data register value can be moved to the accumulator. STA. Data register value to be moved to the memory. BUN. In case of this, the branching has to be performed so that the PC address can be changed. BSA. In this case, the branch operation can be performed and PC address can be saved and stored. ISZ. Return whenever the value PC value has to be incremented, when the value can be accumulator value can be 0. So in this way, the memory referenced instructions can be used. What are the register referenced instructions? So referencing the CPU registers for data processing can be performed in the register referenced instructions. Generally, 2 registers are used in this type of instruction. One is the accumulator, the second one is the flip-flop, that is the E-bit flip-flop. And here is the list of resistor referenced instructions. The first one is CLA, clear the accumulator. Accumulator can be loaded with a 0 value. CLE, clear E, flip-flop bit, E flip-flop has to be set with a 0. CMA, complement accumulator, once complement of accumulator can be performed. CME, complement E, E flip-flop can be complemented. CIR, circulate right accumulator and E value. CIL, circulate left accumulator and E value. INC, increment the accumulator. SPA, skip to the next instruction if accumulator can contain the positive value. SNA, skip next instruction if accumulator is containing the negative value. SJDA, skip next instruction if accumulator is containing a 0 value. SZE, skip next instruction if E value is 0. HLT means halt the computer. Next variety of instructions are IO instructions. Generally, these can be used for the peripheral devices for communication. So here the input is used to need the INPR resistor and the flag of FGI. And the output can use it to carry the output character with a OUTR resistor and FGO flag. So this is how these resistors can be connected to take the input and output. From the keyboard, the transmitter interface, here INPR holds the input character. With the FGI status only, the INPR carries the character. And here the output operation can be performed with the help of out resistor and FGO flip-flop the status value. And here is the list of input-output instructions. INP means input character to the accumulator. OET means output character from accumulator. SKI skip on input flag. SKO skip on output flag. ION interrupt on. IOF interrupt off. So these are the list of input-output instructions. How they can be used in the program. INP means input ASCII character. Out means output ASCII character. SKI means skip if input flag FGI is equal to 1, then skip. SKO means skip output flag FGO is equal to 1. In this way, IO instructions can be used. So, 3 types of instructions: memory referenced instruction, register referenced instruction, and IO instructions. Next, describe the basic computer organization. Illustrate the basic computer organization. So, the functional units of the computer we discussed. Now, how they can be organized. In the top level view of the computer functional units, if you visualize, majorly 4 components can be identified. The central processing unit, main memory, input output, and the system interconnections. So internally, how these can be connected, that can be referred as a basic computer organization. So here, internally within the CPU, 3 subunits are located. They are memory, arithmetic and logical unit, control unit. These are the 3 subunits of the computer. Memory can be used for storage purpose, and it is continuous array of storage locations. Each storage location of the memory can be uniquely identified by the memory addresses. And this memory can be connected to the CPU via the external bus. The external system bus can have 3 buses. One is address bus, second one data bus, third one control bus. Address bus is used to store the address or location of the memory. Data bus carries the what data has to be read or written from the memory. Control bus specifies what operation to be performed on the memory, either read or write operation. Within the internal to the processor board, the internal bus can be used to connect the ALU control unit and the resistors. So here the ALU can perform the arithmetic and logical operations. It requires the operand can be stored in the input register 1 and 2. After processing, the result can be stored in the output register. And in case of any temporary resistors used for the process, these general purpose resistors can be used. They are ranging from R0 to Rn-1 depending upon the processor. Next, the program is a collection of instructions. Each instruction can be executed with the help of instruction cycle, which consists of 4 steps. One is fetch the instruction, second one decode the instruction, third one fetch the operand, execute the instruction. The instruction can be fetched in the first phase of the instruction cycle. It can be retrieved from the memory and stored in the instruction register. Next instruction being executed, the address can be stored in the program counter. That is the fetch cycle. After that, decode of the instruction can be performed with the help of instruction decoder. What is decoding means? The instruction can be represented in the instruction format. Just now we discussed the 3 types of instructions. Memory referenced, register referenced, IO referenced depending upon the opcode. So that format can be represented with the instruction decoder in order to fetch the operand depending upon the type of instruction. So in the third step, the operands can be retrieved from the memory and stored in the input registers of the ALU. And the ALU can perform the execution and the result can be stored in the output register. So all these are the operating steps of the instruction execution. So within the CPU, how the components can be connected, we discussed. But all these are connected with the bus. So this is the layout of the bus. So a bus is a communication pathway connecting 2 or more devices. Okay. So there are a number of interconnections can be possible. More number of devices to be connected to the bus. So single bus and multiple bus structures can be used. So if it are more devices are connected, propagation delay, losing of some data, execution response times can be delayed. So multiple bus system can be generally used. So bus is the major interconnection mechanism in the computer. So by using this bus, how the functional units can be connected. So within the CPU, how this memory can be connected with the system bus and how these peripheral devices are connected via the interfaces can be described with IO bus and interface module. So here these are the various peripheral devices and those can be connected to the system bus via the interface. So from the top level, the central processing unit, within that how the subunits can be connected and how the peripheral devices can be connected and how the instruction can be executed can be described with the basic computer organization. So how the ALU can perform these arithmetic and logical operations. So arithmetic operations are addition, subtraction, multiplication, division. Logical operations are and not exclusive are. To support these operations, 8 basic operations, 3 control lines are used, C0, C1 and C2. So depending upon those input, the basic operations can be performed. The input operands can be available in the registers A and B. After processing, the output can be stored in the C. C is equal to A operation applied on the B. So in case of the C2 is equal to 0, then arithmetic operations can be performed based on the C0, C1 and C0 values. If it all 0, 0, addition is performed. 0, 1, subtraction. 1, 0, multiplication. 1, 1, division. In case of C2 is equal to 1, logical operations are performed. If it all C1, C0, 0, 0 or operation, 0, 1 AND operation, 1, 0 not operation, 1, 1 exclusive OR operation. So in this way, the basic computer organization can execute the instructions. Next question. Explain in detail about the instruction cycle. So instruction cycle typically the sequence of instructions which are arranged in a loop given to a simulation software or a processing hardware unit. So each instruction of the program can be executed with the help of instruction cycle. So instructions are stored in the computer memory. Each time the processor unit follow the 4 basic steps for execution of the instruction. Fetch the instruction, decode the instruction, read the memory addresses so to get the operand value, execute the instruction. These are the steps of the instruction cycle. So, fetch instruction, decode instruction, read address from memory, get operand, execute the instruction. So, these are the steps of the instruction cycle. During the step 1, fetch instruction means from the memory, the instruction can be read and can be stored in the instruction register. Second step is decode instruction. The instruction can be represented in the instruction code format. That is 0 to 11 bits to represent the address. Next 3 bits are used to represent the opcode. The last bit is used to represent the addressing mode. Next, based on the instruction type, whether it is memory reference, register reference and input-output instruction, the operand can be read. If operand is available and opcode can be available, so instruction can be executed. So consider one example that execution of instruction add. So in this, the basic steps are get first number and is stored in A, get second number and stored in B, decode instruction, do the plus operation, write the answer. In this case, the steps 1, 2 are the fetch cycle, third one is the decode, fourth one is the execution. So what is the fetch cycle? So the fetch instruction is loaded to a register in the processor known as the instruction register. So in general, these actions follows 4 categories. From processor to memory, data may be transferred. Processor to I/O, data processing may perform some arithmetic and logical operations on data. Control instruction may specify the sequence of execution that can be altered. So during fetch cycle, what RTL operations can be performed? The PC value can be moved to the MAR register. The content of MAR register can be moved to the MBR and MBR can be moved to the instruction register. PC can point to the next instruction. During execution cycle, the data transfer for implementation takes place in 2 methods. One is processor memory. So data sent from processor to the memory or from memory to processor or between I/O devices the data transfer can take place. Now the flow of execution instruction cycle has to be represented here. So the start and sequence counter can be initiated to 0. So here PC has to be moved to the address register. Next, address register content can move to the IR. So here this is the fetch cycle. Here the instruction is stored in the IR and PC can point to the next instruction. So this is the fetch cycle. After fetching, the decode operation can be performed. During decode, the instruction can be represented in the instruction format. So IR 12 to 14 is the opcode. 0 to 11 can be stored in the address register. IR 15th bit is the I value. So for the memory referenced instruction, the opcode can be 000 to 110. In case of other two, the register referenced and IO instruction, the opcode value can be 111. So to decide this, here the value can be compared whether it is 0 or 1. So if it all 0, it is a memory referenced instruction. If it all it is 1, it is a register or IO instruction. So it is a memory referenced instruction. So I value can be evaluated here. Why? Because if I value is 0, it is a direct addressing instruction. If I value is equal to 1, indirect addressing instruction. In case of direct addressing instruction, the address that is specified in the instruction, there the operand can be available. So I is equal to 0, it is direct, the operand is available, execute the instruction. So this is the decode step. And third step is getting the operand. Fourth step here is the execute. In case of I value is equal to 1, it is an indirect address. So to fetch the operand, again one cycle can be required to get the operand and execute it. So in case of resistor and IO referenced instructions, those can be decided with the I value. If I value 0, it is a resistor referenced instruction. The operands are available in the resistor, execute the instruction. In case of I value is equal to 1, it's an IO instruction. Take from the IO peripheral devices and execute the instruction. So this is the way of executing the instruction. What are the states that can be available during the instruction cycle? So instruction address calculation. So fetch the next instruction, fetch instruction. Instruction operating decoding can be done. Operand address can be calculated, fetch the operands, data preparation. So operand address calculation, store operand. So like this the instruction cycle can be executed. So the basic states of instruction cycle are instruction address calculation, instruction fetching, instruction operation decoding, operand address calculation, operand fetching, store the operands. So that is the instruction execution cycle. The next question is, explain important steps for computer design. So designing the computer is a challenging task. So here the basic software and hardware features can be considered while designing the computer. So at all level, the functional organization, the logic design, the implementation features, all can be considered for the computer design. Implementation can be majorly concentrating on specifying the ICs, what packaging, what noise, power, cooling methodologies, all can be considered. So here the qualitative aspects has to be considered here. During the software compatibility, it has to take the object code high level languages what are to be used, and in the application areas whether the system is used for general purpose or scientific notations or special purpose. Like that, the application area can also be considered during the design of the computer. Operating system requirements, standards can also be considered. So the operating system requirements, the features that can be considered are size of address space, memory management, context switching, interrupts, how the interrupts can be handled, and the standards are how buses can be considered, how many buses are there, either single bus or multiple bus, how floating points can be represented, networking and how networking issues can be addressed. All these features can be addressed. These are the important aspects of the design. So while designing, we have to think about the future. Design today for the tomorrow's market. So the integrated circuit technology can drastically change. So the transistor count on a chip can be increased by 25% every year. And device speed also be considered increases almost the same pace. Semiconductor RAM increases some 60% per year. Disk technology can also be increases 25% per year. So these rapid increases and recent trends during the hardware and software can be considered for the computer designer. The designer must also aware the software trends, the amount of memory required for application execution, and the compiler technology can also be aware by the computer designer. So these are the major designing aspects. Find the basic components of a microprocessor. So microprocessor is the brain of the computer. So which does all the work. It is a computer processor that incorporates all the functions of CPU on a single PC. So entire CPU functionality can be fabricated on a single PCs or few PCs. Microprocessors are first introduced in 1970s. 4004 was the first microprocessor, and this is the layout of the microprocessor. So here also the architecture input device is there. Microprocessor can perform the processing with the help of ALU, control unit, resistor array, and in association with the memory unit and the output device. So the basic components of the microprocessor are CPU, bus, and the memory. CPU can be constructed with the instruction register to hold the instruction that is being executed. Decoder, it decodes the instruction and sent to the ALU. ALU performs arithmetic and logical operations. Registers are used to store the temporary values to increase the processing speed of the microprocessor. The bus can be, 3 buses can be generally used in the microprocessor: data bus, address bus, and control bus. Memory can be of 2 types, RAM and ROM. So these are the basic components of the microprocessor. Next, classify the different types of interrupts in a microprocessor system. So here, interrupt is a signal that requires the processor to suspend its current execution and service the occurred interrupt. Okay, the interrupt service routine can be serviced whenever an interrupt has to be raised. After execution of the interrupt service routine, the processor resumes the execution of the suspended program. So here is the user program. The instructions are generally executed in a sequence. Whenever an interrupt occurs, it has to move to the interrupt handler. This is the ISR, interrupt service routine. These instructions can be executed and returned to the main program execution after giving service to the interrupt. So consider an example here. The add instruction, how it can be executed. So getting the first number and storing in A, getting the second number and storing in B, decode operation, addition operation, writing the answer. So 1 and 2 is the fetch cycle, 3 is the decode cycle, 4th one execution, 5th one is the write operation. But there is an interrupt in the end of the step 2. So the sequence has to be stopped here. Okay, after step 2, the instruction processing can be stopped and ISR can be executed After execution of ISR only these steps can be, the main program steps can be executed. Interrupts are of two types: hardware interrupt, software interrupt. Hardware interrupts are again classified into maskable interrupt, non-maskable interrupt. What are hardware interrupt? If a processor receives interrupt request from external I/O devices, so that is referred as hardware interrupt. From the peripheral devices, the interrupt can has to be raised. Those can has to be generally referred as hardware interrupt. The hardware interrupt are again two types: maskable and non-maskable. Maskable interrupt can be ignored or delayed for some time if the processor is executing a program. Whenever, for example, this is the main program and this is the ISR. If interrupt is raised at this stage, if at all it is a maskable, then it can be delayed and the execution sequence can be continued. Those are the maskable interrupt. In case of non-maskable interrupt arises here, it immediately switches to the ISR and interrupt service can be done. That is the two categories, maskable and non-maskable interrupt. Second category is the software interrupt. Software interrupts are the interrupt that occur with the condition met or by using the system calls. The software interrupt can be raised. So these are the two types of interrupts. Compare different kinds of ROM. ROM is a type of memory. Memory is generally classified into primary memory, secondary memory or auxiliary memory. Primary memory is main memory and it consists of RAM and ROM. RAM is random access memory. ROM is read-only memory. ROM is only used to allow the single operation, read operation. And it is a non-volatile memory. Whenever power interruption occur or switched off, the content of the memory cannot get erased. And variety of ROM is PROM, EPROM and EEPROM. So what are these varieties? Variety, the types are masked ROM. So here the connections made by the semiconductor vendor. So here setup cost several weeks of delivery, high volume only. Bipolar and it's a MOS technology can be used in the masked ROM. PROM means programmable ROM. So here only read operation can be performed. But in case of PROM, one-time programmable can be done. It is also uses bipolar technology. EPROM means erasable programmable read-only memory. So here the content can be erased with the help of ultraviolet rays. And the limited number of erasures can be 10 to 100. EEPROM or E-square ROM means electrically erasable ROM. Here the erasures can be done with the help of electrical signals and the number can be limited to 10,000. Next, flash memories, electrically erasable in blocks, and here the array cycles can be more in case of flash memories. So these are different kinds of ROM. So the random access memory is category of the memory and can perform read-write operations. But in case of ROM, only read-only memory. So erasure cannot be possible in case of PROM and ROM. And the mask operation can be done in case of ROM and PROM. In case of erasable PROM, EPROM, E-square PROM, flash memories can be used. They are read most only, but with the ultraviolet rays, the erase can be performed in the EPROM. With electrical signals, the erasure can be performed here. On-chip erasure circuit or block level can be performed in the flash memory. So all our ROM is of non-volatile type. So this is the comparison of variety of row. Explain instruction set architecture, give example. So here we are having various layers of abstraction. The application, the algorithm, programming language and assembly language machine code. Until this is the software category. And below that the hardware can be placed for the execution. Devices, gates, microarchitecture can be there. So ISA instruction set architecture is an interface between software and the hardware. So here whenever an application, it has the user interaction with the help of operating system compiler and assembler, it can be converted into the machine code, which can be taken by the instruction set architecture as an input and activate the necessary hardware below that, the processor, memory, IO system and all this circuitry. So the ISA is placed in between software and hardware to act as an interface between software and hardware. So an instruction set architecture is part of the abstract model of the computer that defines how the CPU is controlled by the software. ISA can act as an interface between hardware and software. What ISA can specify is the memory model, the instruction format, addressing modes, operating registers, data addressing types. All features can be specified by the instruction set architecture. And variety of models are available. Popular ISA are reduced instruction set computer RISC, complex instruction set computer CISC, minimal instruction set computer MISC, very long instruction word VLIW, explicitly parallel instruction computing EPIC, one instruction set computer VERSIC, zero instruction set computer JISC. So these are the popular ISAs available in the market. Next, compare the computer architecture and organization. So computer organization can be concerned with the way the hardware component operate and the way they are connected together to form the computer system. But organization is also referred to explain how the operational units and they are interconnected to realize the specifications. So CO focus on the control signals, interfaces, memory technology, all these. The another term that involved is the computer architecture. The computer architecture is concerned with the structure and behavior of the computer. So it refers to the attributes of the system. So it is generally the user perspective, how the logical execution of the program can be treated. The architectural deals with the instruction set, instruction format, IO mechanisms, memory addressing techniques. So we have to compare the computer organization and architecture. The organization is generally treated at the micro level or low level. Computer architecture is somewhat high level, it is user perspective, but organization is machine perspective. So transferent from programmer, the organization. So programmer's view has to be considered in the architecture. The physical components can be more concentrated. The logical execution can be more concentrated in the architecture. How to do can be specified by the organization. What to do can be specified by the architecture. So these are the difference between computer organization and architecture. Illustrate memory unit function. Memory unit is used to store the program and data. The basic design issues of the memory can how to CPU processing speed can be affect the storage capacity, the storage capacity of the programs and data, and how inexpensive, reliable and energy efficient memory can be constructed. So memory can be a collection of storage cells together associated with the circuitry. So memory stores binary information in group of bits called the words. The internal structure of memory unit separated by number of words it contains and number of bits in each word. So here special address lines can has to be selected for one particular word. Each word in the memory can be identified with a unique number that is called the memory address, and it is ranging from 0 to 2n-1. So this is the scale of the memory. 1 bit is binary digit, either 0 or 1. 8 bits is 1 byte. 10024 bytes is 1 kilobyte. 10024 kilobyte 1 megabyte. 10024 megabyte 1 gigabyte. 10024 gigabyte 1 terabyte. 10024 terabyte 1 petabyte. 10024 petabyte 1 exabyte. 10024 e-byte zettabyte. 10024 zettabyte yottabyte. 10024 exabyte 1 prontobyte. 10024 petabyte 1 gigabyte. Gigabyte is the highest memory scale. How this memory unit is connected with the CPU. So this is the processor. Processor can contain MAR and MDR register, memory address register and memory data register. And memory is consisting of 2 power k addressable location. Why? Because there are k bit address bus lines and this MAR can hold the location of the memory. And the word length can be n bit depending upon the n bit data lines. MDR carries the data that can be read or written from the memory. The operation what to perform can be specified with the control line, either read operation, write operation, memory function complete. Like this, these signals can be carried with the control lines. How this memory can be considered? So based on the classification of memory, you know that primary memory and secondary memory are of 2 types. So the primary memory can be cache memory, RAM or the ROM. RAM is the major memory, random access memory, and it is of SRAM or DRAM. It is a volatile memory. It is used to perform both read and write operation. ROM is read-only memory and it is a non-volatile memory, and various varieties are PROM, EEPROM and EEPROM. To extend the storage capacity, here the secondary or auxiliary memory can be used. So they are the magnetic tape, magnetic disk, optical disk, flash memories. So how these devices can be connected with the memory subsystem interfacing. So this is the main memory, this is the RAM memory, and it is connected with the CPU, and this is the cache memory, a small high-speed memory that can be placed between main memory and the CPU. And via I/O processor, the auxiliary memories devices can be connected with the main memory. In this way, the types of memory can be connected. So the CPU registers are very fast and low storage capacity. Next, the cache levels, 3 levels can be employed: L1, L2, L3. Main memory, secondary memory are the major. This is illustrated with the memory hierarchy. When you traversing from top to bottom, the performance has to be increased, and cost per bit can also be increased. When you traverse from bottom to top, the performance cost per bit can be increased. When you traverse from top to bottom, latency and persistency can be increased. State operations of the control unit. The control unit is the subunit of the CPU, and it is used to control and monitor various operations of other functional units with the help of clock signals. So here generally 2 devices that can be required in the control unit are central processing units and graphical user processing unit GPUs. So with the help of clock signals, the control unit can control the functions. So here this is the instruction register. So depending upon the instruction decoding, control signals has to be generated, so that the flags and with the clock signals, The rest of the buses has to be controlled to take data and for execution of the program. The design of the control unit can be hardware controlled or the microprogrammed control. In the hardware control, the control logic to be implemented with the gates, flip-flop, decoders, the hardware components. So here this is the hardware control unit. In this, the control logic has to be, this is the instruction register, and here the address bit can be represented here. The opcode can be 12, 13 and 14 bits of the instruction register. So it can be connected with 3x8 decoder for the decoding purpose. The 15th bit is specifying the addressing mode and it is connected with the high flip-flop. Here the clock signals, the sequence counter has to be generated the clock signals to decode the instruction and to fetch the operand from the memory depending upon the type of the instruction that is decoded. The second variety of control unit design is the microprogrammed control unit. Here the control organization is implemented with the programming approach. So this is the block diagram of microprogrammed control unit. So here the next address generator is the sequencer, control address register, control memory, control data register. In order to access this control memory, control address register, control data register can be used. For the next instruction sequencing, next address generator can be used. So these are the two designs, that is hardware control unit and microprogrammed control unit. In case of hardware control unit, the main logic can be designed with the help of the hardware devices. But in case of microprogrammed control unit, the programming logic can be employed. The design of computer is complex in case of hardware control unit. The design of computer is simplified in case of microprogrammed control unit. The architecture and instructions set are not specified, but here instruction set is specified. Hardware control unit is quick, it is moderately comparatively slow, and the control logic, the processor creates signals to be executed in a right sequence, but the instruction can be decoded and executed in case of microprogrammed unit. It operates through the need of drums, flip-flop, all these electronic elements can be, hardware elements can be used. But in case of microprogrammed unit, ALU, resistor, buses can be used for the execution of the instruction. So these are the two varieties of control unit designs. So these are the question bank questions that we have discussed in detail in this video. Thank you.
Like, share and subscribe. Hit the bell icon for more updates.